All right. So you guys can see my screen, I'm assuming?
Yes.
All right, so I'm talking today about interpolation expression sequences, which most people know as string interpolation. And I just want to quickly just look through the spec, which is a little bit technical, but essentially what we're trying to do is we have a interpolation string literal, looks like this, and it transforms this into a sequence of tokens or a sequence of expressions. We get an interpolation header, we get an interpolation literal for anything that's actually string literal data. We get an interpolated expression for the thing that's inside here, and then we get the actual thing passed in. So name gets passed in as part of the sequence, and then finally it ends with an interpolation footer. And we're going to see this in the code as I show it to you. But it's a little bit more complex than typical string interpolation. So I have this blank dev app we're going to put in here. I'll just put in quickly. What we're gonna do is I'm gonna write an overload of printf that takes interpolation sequences and does it all without with basically the minimal runtime code possible. So we'll start with I'm gonna import both this and CIO. I'm gonna need some stuff from std.traits, and let's just quickly go. Okay, so int name, and we'll just give it a couple variables here. This is a lie, but that's okay. And we'll just say printf. And then if we want to write a string to printf, we have to use this .star syntax, and I'll show you how that works, because you can't pass an actual string to printf. You have to pass the length and pointer. And we'll say is old, and we'll say name.length, name.pointer, and 42. So basically that .star is saying first you're going to get an argument that's the width, and then you're going to get the actual string argument. Okay, so let's see how this works. And we have an error because I typed something here wrong. All right, no return statement. Let's get through this stupid easy errors. All right, so we got this hello Steve, I see you, they're 32 years old. It says this deprecation must be int, not ulong. So really what we should be doing here is casting this to int, even though for all practical purposes it's not going to make a difference. So cast int. All right, so that should get rid of the warning. All right, so this is standard printf stuff. Now we want to use interpolation string. No, by default, because interpolation literals have automatic two-string members for them, you can just pass an interpolated string right to writeline. So I can do basically the same thing. And we should get essentially two exactly the same outputs. But how does this work? So first we're going to let's create an overload for printf. So in order to create an overload, I have to do this so that I have two functions of the same name in the same module. But I'll do this quickly here. We'll say auto printf, and we'll just take some args. And all I'm going to do right now is show you what the args are, so you can see how it works. And I'm going to do the same thing, except I'm just going to pass it to printf, which is our temporary printf here. And we'll see from the compilation, this is what we get. This list of types. I'm just going to paste this in here so you can follow along with what it is. So the nice thing about this is we have printf, which takes a string, and we have printf, which takes just random stuff. Now, because printf, the original printf is a normal function, not a template, it gets priority. But you can actually create an overload that will only take interpolated strings by taking a non-template parameter first. So first we have to import core.interpolation, and we're going to copy this interpolation header. We don't need a parameter for it because it's just a marker to allow you to overload. And footer. And now we should get basically the same thing, but without the header and footer in there for args. So let's remove those. And now we need to process these parameters. So if you look at the way this works, we get a parameter for each piece of the interpolation sequence that is text. So this is text, hello, with comma with a space. And then the next thing we get is an interpolated expression with another string. That is actually the piece that's inside the interpolated literal here. And finally, the last thing we get after that is the actual data. So this is the string name, which is this guy coming across. Then we come out, we get another string, ICUR with a comma in front, and then the expression, which is the age, the string age, and then the actual age, which is an int. And finally, we end with another interpolation literal with the string. I actually need a \n there, so I can put that here without running it. Oops. All right, so how do we process these? For those unfamiliar with compile time stuff, we're going to do some of this kind of at compile time, but also at runtime, just to make it easy to understand at first. So what we need to pass to the actual printf is we need a format string that looks like this. We need this exact format string. So how do we build that? We just loop over the arguments. So we're going to do static for each. And by the way, anyone interrupt me because I can't see, I'm not looking at the chat. You can see what I'm looking at. But if you have any questions along the way, interrupt me by unmuting. All right, so we're going to need also the parameter number here. And I'm just going to do all the arg types. So this is going to give me each, let's change this to T. So each type is going to come in that's everything but this interpolation header. So this basically this list is going to come through here, and I is going to be the index in that tuple. So we're going to find out, first we're going to get this interpolated literal. So we have to handle interpolated literals by adding them to the format. Oh, we actually need a place to put this. So string format. So static if, we're going to use from std.traits is instance of, actually literal t. So if we get an interpolated literal, then we're going to say, add that directly to the format, because that's just string text. And this is going to be args I dot to string, because each one has its own string. All right, else static if is instance of interpolated expression. So these ones, for this particular case, we don't care. Like, we're not going to do anything with name, the text name or the text age. But if we did want to do something with it, it would be args I dot expression, I think, right? So you can get that information. And then finally, we have to handle all the types that printf. So printf uses, you know, writef uses percent. You can just use %s and it always works. Well, with printf, you need to actually pass the correct expression. And in fact, in this case, we need to pass something weird here, this %.*s. So let's deal with that. And for this, we're just going to use a standard is statement. If we get a string, then we're going to say fmt equals %.*s.
Got some comments in the chat, Steve.
Okay, let me check it out real quick. Yes, we would have to, if we wanted to do that, you could replace percent with a double %. But the only thing about that is you can also do that with your, you know, with your thing. And if you're using printf, I think that you're able to do that. But yeah, I agree. It would be better to have an automatic replacement of that.
And there was also a question about type of.
I'm sorry?
There was also a question about type of.
Oh, type of is not parameterized. Type of, so type of gives you the type of an expression, but we already have the types. The types are args with a capital A. The expressions are args with a lowercase a. So I'm just iterating over the capital expression. Does that answer the question? I should go back and look. But in any case. All right, so if you have more questions, you just type them in and I'll get to them. All right, so if we're doing a string, we do that. Else static if is t equals int. Very simple. %d. All right. And finally, we probably want to just reject anything else because we don't know how to handle it, or haven't written the code. Like you could go through and put %f and whatever for all different types, %c, but you know, in this case, we're just doing a simple demo. Okay. And now we can say, because we're doing this at runtime, we have to show it at runtime, but we can see that if we run this, we're going to get some errors, of course. Okay, I put args. Where is this error? 12. Forgot my bangs. All right, there we go. So now we can see we got the exact text, this, and I put right line, but there's already a new line, so that's why you got 2 lines there. But you can see we got the exact format string we need. Okay. The next thing we got to work on is the actual argument. So after you pass the format string, you got to pass all these arguments. And for strings, we have to do something weird where we pass the length and the pointer. So for that, we're going to need a mixin. But let's just do it with in runtime first to show that it works. So we say string arg argmixin. And let's do very similar to this. Now, since we've already gone through all the arguments and we've rejected any ones that aren't what we care about, we don't have to do that again. But we do need to still not put out arguments for the interpolation pieces. So I'm going to leave this here. And so if we get either an interpolated expression or interpolated literal, we're going to do nothing. Otherwise, if it's a string, we're going to have to output something that gives us the arguments. Now, our arguments came in as a tuple in args, so we're going to have to use that tuple. So it would be args, and then i.stringOf dot length. So first we need the length, and of course we need the cast, and a comma for the next arg, and then args i.stringOf dot pointer. So this should give us exactly the same thing as here where we passed name.length, name.put, but this time it'll just be args, whatever the argument is, because it passed in on that spot. Okay, so we passed that in. This one's even simpler, and in fact we can just ignore the type at this point because it's already been validated. We don't need this else. And we can just put args i.stringOf comma. Okay, we can always use a trailing comma in argument list, which is great because it makes I don't have to deal with doing funky like trimming off commas. And finally, we can write this as well. And if we run that, we get exactly what we're looking for. We didn't get exactly what we're looking for because I'm missing the integer because I added it to fmt. Oops. All right. So args2 length, args2 pointer, and args5, which is the fifth parameter. So we have 0, 1, 2, 3, 4, 5. So that makes sense. All right, so how do we use these to build our actual printf call? Well, obviously format we can just use because printf takes a format at runtime. But argmixin needs to be at compile time. So let's put this at compile time. Instead of this, I'm going to say enum argmixin equals, and this is a cool technique you can use. You basically put a lambda, and then at the end of this, we're going to return argmixin. Format that real quick, and now argmixin is now a compile time string. This should still work. What did I miss here? I missed the actual call of it. So that created the lambda, but I didn't actually call it. I forgot the semicolon. So that should work now. So we get the same thing, but now it's being generated at compile time. And finally, we don't need the format at compile time, but we can do it anyways. So let's do that. And just to make sure that we have a good C string, I'm going to put if I can type, I'm going to put a 0 terminator at the end and call it format, and now we have basically 2 compile time strings we built. And finally, now that we have that, let's take out these debug write lines, and we're going to call our printf call. So we're going to say mixin, or return mixin printf FMT. We can just use the FMT because it's there with a comma. And now we just also add our arg mix in, which is the list of all the arguments we're going to pass, closing parentheses, and we should be done here. So this should work. Oh yeah, I have to put dot pointer here. Here we go. So now we've called printf using the dfeature interpolation expression tuples. And something that's really cool about this is, let me get rid of the right line and let me make this extern C, no GC, no throw, and still works. And I can even change this to say we're going to do this in better C, and it still works. So using better C, we can still, there's zero dependencies on the runtime. It just needs the templates from core.interpolation. Is there any questions so far on this? Okay. So can you change text? I'm not sure what you mean. Sorry. For the second printf? Change text. Oh, so that it you can tell that it's doing something different. Yeah, we can do that. Just there you go. I can do that. That sounds good. All right. So that's interesting, but it doesn't allow us to do any formatting. We're doing default formatting. And I don't really want to do this for printf. Printf is kind of boring. So what I'm going to do is I'm going to forget about this. And I actually already did this for writef. I did post it in the Discord, but I'm going to go here. I created a better writef thing that basically does the same thing. We have to get rid of these because we're now back in D land. We don't need no GC in that crap. Let me take out the better C option. And let's get rid of printf. And we're going to do instead writef, which is this is now essentially the same thing, but it with a little twist. So let me make sure this is overloaded. So we can do writef. Basically, let's just do the same thing here. %s, we can use %s in here. And name age. That should work. So back to our normal, we do writef. Yes, okay, that's working. So now we're going to call our writef with an interpolation literal. I'm just going to paste it. But this time I'm going to say age. I'm going to change this. I'm going to actually leave this thing here, and I'm going to put a hexadecimal. So what we should see is an error, of course. What did I do wrong here? Wow, this worked just fine the last time I did it. Oh, because I actually kept the arguments there, dummy. All right. So now we get the same thing, but instead we've actually formatted the thing. We left our format specifier. And then actually the writef function is much easier just because we can do %s all the time. So what I've done here is I go through the args, and if it's an interpolated expression and we have an argument that we have to put a %s, then we put it, we kind of do it, we defer putting the %s until later. But if that literal is starts with an actual format specifier, which means it starts with a %sign and the second character is not a %sign, so it's not a %escape, then we just skip it and let the format specifier that's there happen, or we'll put in our own %s format specifier. So if we just, so for the first one we don't need a format specifier, it automatically puts it in, but here we can actually do our format. So you can actually have an overload with interpolated expressions that still supports all the format specifiers you possibly can have in writef. And I mean, having this kind of an addition is really straightforward. Oh, and by the way, also because we are building this format string at compile time, I'm passing it in at compile time, right, with this way. So if I put in a stray like %s here somewhere, then it's going to complain it's not even going to build because there's no orphan format specifier. And we can see the possibilities of using this for SQL because we can overload on the interpolation expression. We can detect, oh, this is going to be a, I know which parts are literal and which parts are variable data, so I can actually automatically construct a prepared statement and make sure there's no SQL injection. And there's all sorts of different things. Adam actually posted a repository with a bunch of them in it. It's really nice. And as long as you're comfortable with some of this is kind of a little advanced to have to deal with tuples, but I mean, if you're using D all the time, dealing with tuples is something you should learn anyways. But this does make it really easy to, I mean, this is a direct call, right? Like this thing is probably going to be inlined to be this exact call, so you won't even see this function call in the call stack. It's just like you wrote what you intended to write. And that's it. I don't know if there's any questions on this or anything else.
I was just envisioning writing a MUD or a Quake console with this stuff. That would be cool.
Yep. Yep, you can do validation of the queries at compile time actually, because remember, all the data comes in as compile time parameters to the interpolation literals or interpolated literals and interpolated expressions. So you can validate everything in there at compile time if you want to.
Validate, filter.
Yep.
Replace.
You get all that power. And that's one of the reasons why we went with this instead of just a simple string replacement. String replacement would require allocations and rewriting the expression as the, I don't want to harp too much on the other dip that Walter proposed, but the biggest problem I had with that is the compiler parsed out the whole thing and then recreated a new puzzle for you to have to parse out at runtime, which I found pretty unacceptable. I'd much rather just have it tell me what it parsed. All right, well, I think that's, without any more questions, that's pretty good. Thanks. Yeah, I think it's pretty good. I will post this recording at some point, and yeah, go ahead and play around with it. And if you have any questions, you can ask me on Discord or the forums or whatever.